Okay, let's talk about the final projects a little bit. The basic outline is that you're going to define some very specific objectives in your project proposal. And then you'll submit that. I'll give you some feedback, help you kind of constrain the scale, the complexity, maybe add to the scale or complexity, and turn that around to you, and then you'll redefine it. As you work through it, you'll be submitting updates to me, and I want you every single update to redefine your objectives for your project. It'll help you stay focused, and it's definitely going to change as you work through. So the first step is defining your project and defining the goals. Second, you're going to acquire the data that you need. Sometimes this will force this to change because you can't get what you need or imagined you could get, or you might find something so stimulating that your original idea is out the window. You're going to perform some analysis, and this will iterate. As you do that, you'll realize you need more data or you've got the wrong data, which will iteratively force you to redefine your objectives. So that's why each week I have you submit an update for me because, to help you stay on target. All right, interpreting results. Yes, visualizing your results. Don't underestimate how much time this is going to take. You will present your project for some feedback, and then have time to, do additional analyses to fill gaps or to correct errors in your assumptions or workflow, and then finally write up the results for evaluation at the end. So what might you work on? Well, one idea that we use for the introductory course but can grow into something quite large, and I think it's a good stepping stone, is to think about defining remoteness. For example, use a complex set of GIS analyses or tools to identify the most remote location in Cache County or in Utah or in the whole US. So how do you define remoteness? Well, that's where the fun comes in. Maybe it's the best, backcountry location for some exercise, hopefully with a low carbon footprint. So you might incorporate slope and aspect, avalanche history data, land ownership data, accessibility data. There's tons of things you could do with this. Maybe you're a rock climber and maybe you're not a rock climber and you feel like if you could build an evil lair on the side of a cliff, that would be great, but you need to be close to a Starbucks. So you define what the inputs are for basically a habitat suitability model, right? It could be just about anything. You find the data, you make up the rules. Maybe you are the animal that you're modeling the habitat for. Lots of stuff out there. Go find some good data. Whether you're working on a project that is, something that you invent yourself or is inspired by data that you find or a subject that you're studying in another course, you need to consider the complexity of your project and make sure it's fitting the overall, needs or expectations for the project. You do have to have a complex set of steps or tools in your workflow. It's not just a visualization exercise. So plan on calculating a lot of things and exploring new tools that maybe you haven't used before. Download some unique data that you've never worked with before. What I mean by composite layers is that you're running a tool and getting a new output and then using that output as the input for the next step. So kind of a classic flowchart work through. And then, of course, deliberate cartography, deliberate communication of your results. I haven't decided yet if the final output should be a poster, like kind of a classic science communication poster, or if it'll be a manuscript of some kind. I may choose to leave it up to you. A poster is a lot of work because you have to put a lot of effort into the visuals. You can't just slap it together. If you choose a poster option, you would be, of course, evaluated on the hierarchy of the text and the images and, the scale of all the different fonts, whether it's a label in a map or, an axes label on a chart. Everything has to work together. So that is a lot of work. A manuscript is going to be in the IMRAD format, Introduction, Methods, Results, hopefully leading with the most exciting stuff up front. All right, last year, here's just a sampling of project titles from spring of 2020. Yeah, we were doing a lot of GIS back then. A Safer America, Understanding Terrorism Patterns in the United States. So this student found some contemporary terrorism data, local, national data for the United States, and did some geostatistical analyses on them, tracking patterns changing over time. Determining potential mountain bike trail systems using GIS. So this was somebody who's just really into mountain biking and took elevation data from, I think it was all of northern Utah. And then, did a bunch of calculations to determine kind of the ultimate, an ultimate trail system. West Nile virus cases in the western United States and Utah. This was looking at a geographic spread over time. Again, it was inspired by finding a really great data source. So if those of you who are stuck, get online and Google GIS data, free GIS shape files. If you're interested in a particular topic like global pandemics, Google it. The data is out there. Everyone is making their data available nowadays. Do aspen stands reduce fire severity and stop fire spread? This was a student working with a faculty member who gave her access to an enormous amount of data. Wildland fires within the wildland-urban interface throughout Utah. This was kind of a dual project where the wildland-urban interface, first of all, was mapped just by using proximity tools, and then a history of fires throughout Utah was overlaid with this mapped interface area. A deductive habitat model of 2 different Utah bighorn sheep species. So where do we see them? And then what are the common characteristics of those landscapes? Racial minorities and industrial pollution density. So taking census data and mapped, what are they called? Superfund sites, sites that are being monitored for air pollution, known water pollution sites, things like that. And then the proximity. Great Salt Lake's influence on migratory birds using eBird data. Horned puffin movement over time. This was pulling out specific species from, I think, eBird. Finding drivers of microplastic deposition in the Intermountain West. This is a really cool project. Again, a student working with faculty who they knew had a really great data set and they wanted to play with it. Remote sensing. Don't forget Lane Kopic is looking for somebody to help him use remote sensing and GIS to look at land use change over time in Kenya. This is a really huge project, potentially could turn into published papers. The results of your work will be used on the ground, and it could, I say 2 students, but this could handle as many students as wanted to tackle this. This could be pulled into a lot of different chunks. So yeah, just for some inspiration, but like I said, you can go after faculty that you know do interesting research. You could take a topic from a class that you really enjoy, look at the headline news, and just go search free GIS data and see what you come up with. All right, that's it. If you have questions, let me know.